So what's behind all of these applications is the idea is we go into the laboratory, and as synthetic chemists, we can make all kinds of polymers, small molecules, chromophores, nanoparticles, inorganic structures. We synthesize these, and where the bioorthogonal chemistry comes in is then we have to put these in very precise locations on the protein surfaces. In many cases, choosing between hundreds of available functional groups and pinpointing one single place where we want to put that functionality. And so I want to start out by talking a little bit about how people traditionally modify proteins, and then I'll show you two new ways that we've brought to the table that can help us to solve some of the challenges in building these materials. So the field of protein modification has been around, by my count, about 100 years, believe it or not. The first report I know of for modifying a protein on purpose was in 1905. It was an experiment where they actually were modifying tyrosine residues, the phenolic residue here, and they did this by treating them with these diazonium salts, and what happens is that they turn bright orange through the formation of an azo compound. And the reason that they did that experiment is that they had the hypothesis at the time that maybe proteins contained phenols. This was, of course, before the amino acids were known, and in fact, this experiment helped them to get data to confirm that. Since that time, many other reactions have evolved, and probably the most popular way to modify proteins today is to target lysine residues, which are these amine substituted side chains that are found all over protein surfaces. You can react these with many different agents. In technical speak, it's the NHS esters that are most commonly used. Those will acylate these nitrogens, forming amide bonds, thus putting whatever your R group is, your group of interest, maybe your chromophore, on those specific places. And other chemistries are available for many of the other residues. However, when you want to start to make well-defined materials, there's another consideration here, and this is one of the problems in the field, and that is that many proteins have many copies of these amino acids that are modifiable. For example, in the case of lysine residues, this protein here, triose phosphate